and today we discuss the first model of computation, which is the basic model of computation, finite automata. So in short, you can write FA, and since you have the finite automata, means we are talking about the many FAs. So this is the plural, and for one you can say automaton. So we are going to discuss. Finite automata is one of the basic model of computer we have, and the main thing is here is it has very limited capability to learn. Means it has very limited capability for the story. So with very few memory, with very limited memory, you may think that what we can do with extremely limited amount of memory. So here you will find that lot of jobs you can do with the help of even the finite automata has the minimum or limited memory. We can do number of jobs. So in day-to-day life also we are encountering such kind of devices which in our real life, once you move outside your home, you may go to the supermarket or somewhere else, you will see the these devices which are designed and on the basis of on the methodology of the finite state machines. So one example for such basic devices you may be encountering somewhere in maybe in the supermarket, the automatic doors. You have the automatic doors. You might have seen somewhere else if you have moved somewhere. So we have, if you have some supermarket, at the entry point and at the exit point you may have the gate, and that gate is automatic, means once you move there automatically gate will be open, and once you walk through the doorway and you have passed, then it will automatically will be closed. So you have some doors which is considered as the automatic door. So you have the door, okay, and how controller of the door would know that it has to open the door. So we have at the front of the door, you have some sensor, and which we can say that this is the front, okay. So this is the front pad we have, and at the back also, in the rear part also some sensor, so that it can sense at the rear part. So you have the rear pad also. So this is the automatic door, you can say that. So this is some top view of the automatic door. So controller of the automatic door, how would know that it has to open the door or it has to close the door? So here you have the door, and we assume that this is the door, and this door can be open like this, okay. This door can be open. So once you move on the doorway, the door can be open, okay. So once you are at this point, once you are at the front pad, then controller of this automatic door. So we have the controller here. So you have controller of your automatic door. Okay. So how controller will know that it has to open the door? So it can open or it can close. So once you are walking through the doorway, then controller is going to sense, and controller is going to receive some signal, and accordingly it is going to open the door. Once you are moving, then it allows you gate remain open, because it allows you to move through the doorway so that you can pass. Otherwise, if it is opening and once you are here and once it is going to close, then it may hit you. So once you move further of the rear pad, so once you are here and once you move, then if controller says that okay, yes, person have moved, then it is going to close the door. So controller of the automatic door is going to receive the signals, and controller has two tasks to do. One is it can close the door or it can open the door. So how would controller knows that I have to open or I have to close? So for that it is going to receive some sort of signals, and we can say that you you may have four different situations. Means person may not be here or may not be at the rear pad. So once person is not here and is not here, then we can say your controller is going to receive the signal, assuming that neither. Okay, for simplicity, we are writing the neither. This means this is the signal controller is going to receive if no one is here and no one is here. Once no one is here and no one is at the rear pad, then what happened? The door is closed. Controller is not supposed to do anything. But in the situation when somebody is at the front, you have the front panel. So you have the front pad, and if somebody is at this front, then what you need to do, you have the rear, you have the rear pad. So what controller can do? So assuming that somebody is at the front pad, then controller is going to receive the signal, say front. You can denote by writing some simple symbols like F you can write for denoting the front. I am writing the front. Front is and the signal controller, your controller automatic door, controller of the automatic door is going to receive. And once it receives the front, this means what? Person is at the front pad. So if person is at the front pad and no one is here, it means what to do? Controller has to open the door. So once person is at this place, then controller is supposed to open the door. This is one situation. Now, if say if it is gate is open or closed, whatever. So and if you instead of person is here and person may be at the rear pad. So there are third situations you may have. So you have the front, okay, you have the front pad, and no one is here at the front pad. But controller says that somebody is at the rear part. So somebody is at the rear pad. It means somebody is at the here. So what to do? If gate is closed, means I'm going to say that controller is going to receive the signal rear. Rear means somebody is at the rear pad of the door. So what to do? If gate is closed, then it should remain closed because somebody is standing here. If you open the door, then the door may hit the person. So controller should remain close the door. Second, if the gate is open, then gate should remain open because once it is going to close the door, then again the door may hit the person. So gate, if it is open, then it should remain open, and once it is closed, gate is closed, then it should remain closed if controller is going to receive the signal rear. What is the fourth situation? In fourth situation, you can see that we have the front here and we have the front pad, and controller sees that somebody is standing at the front pad and also someone is at the rear pad. So we have the situation. So the gate is this and somebody is standing in at both the places. So we can say that controller is going to receive the signal both. Once it is going to receive the signal both, then it means the person is at the front pad and person is at the rear pad. Then again what to do? If gate is closed, then it should remain closed. Even the person is at the front pad, it should not open because if it is going to open, then it can hit the persons. And if it is open, then it should not close because once it is going to close, then the gate may hit the persons. And Also, if it is open, then somebody is at the front, the person can move easily. So these are the four situations we have. So one is neither. Neither means no one is here and no one is here. Front means if your controller is going to receive the signal front, then this means somebody is at the front of the pad and it is moving towards the doorway, and hence if no one is here, it means controller has to open the gate. If person is not at the front but controller is sees that there is somebody at the rear pad, means it is going to receive the signal rear, then if gate is closed, then it should remain closed, and if it is open, then it should remain open. Similarly, if it is going to receive the signal both, then it's whatever is the state of the gate, it may be closed or it may be open, it should remain in the same state. So these are the four conditions you may encounter for the automatic doors. So what you can see that in the case of the automatic door, how many states is there? We have the two states mainly. One is, we can say that gate is open or gate is closed. So we have the two states mainly here. So we can say that, say gate is closed. We can say closed. This is one of these states. Other one, we can say gate is open. There are two situations. Okay, gate is open. We can enclose it within the circle. We can say like this. Okay, so this is one state of the gate, and this is, you can say, other state of your controller. So controller is your controller of your automatic door can be of any one of these two states. Controller can be either in the closed state or it can be in the open state. So now, if assuming that if it is in the closed state and controller sees that there is somebody at the front, means it is going to receive the signal like this, front. If somebody is at the front, means if gate is closed, if your controller is at the state closed and somebody is having the, it is going to receive the signal front because somebody is at the rear front fed and it is walking towards the gate, and it controller has to open it. So what to do? Once it is in the closed state and on receiving the signal front, controller says that, okay, yes, I will open the gate. So on receiving the signal, you can say front, controller is going to open the gate. Okay. What are other possibilities? If gate is closed and controller says that, okay, neither, it is going to receive the signal neither. This means what? No one is at the front pad, no one is at here, and no one is at the rear pad. If no one is at here, then gate should remain closed. So you can say that on receiving the signal neither, your controller should remain in the same state. If it is in the closed state, then it should be in the closed state. So what are the other possibilities? If it is going to receive the signal, for example, rear, gate is closed here, and it is going to receive the signal rear. It means somebody is standing at the rear pad. When somebody is standing at the rear pad, it will remain closed because once you are opening, then it may hit the person. So when it is going to receive the rear signal, rear means somebody is at the rear pad, then gate remains closed. Other possibilities, your controller may be receiving the signal both. So if gate is closed and it is going to receive the signal both, means gate is closed and somebody is at the rear pad and somebody is at the front pad, then gate should remain closed. It cannot open. Your controller cannot open because it may hit the persons. So in this case also, in situation of the both, you can say that both. If it is going to receive the signal both, then it should remain in the closed state. So see, if your gate is closed and your controller is receiving the signal rear, then it should remain closed. If controller is going to receive the signal neither, then the state of the controller remains same, means the gates remain closed. And if it is going to receive the signal both, then controller is remain in the same state. If you talk about the open conditions, so whenever you are at the open state, gate is open, and once the gate is open, and you have the four possibilities here. If your controller is going to receive the signal neither, what to do? If your controller is going to receive the signal neither, means no one is at the front and no one is at the rear. If no one is at here and no one is at here and gate is open, then what to do? Your controller is supposed to close the door. So that's why from the open state, your controller comes to the closed state. Gate was open and it is going to receive the signal neither, and on receiving the signal neither, controller says that okay, no one is at the front, no one is at the rear, so it should close the door. So from open state it transit to the closed state, on which input? The input is neither, means signal is neither. So in the neither, once it gets the signal neither, means this is the input it is going to receive, your controller is going to receive, and hence it can change the state. Now the other possibility is your controller may receive the signal front. So once the gate is open and it is going to receive the front, it means somebody is at the front pad. So what to do? Controller should remain open the gate so that it allows the person to enter to the supermarket. So when somebody is at the front, you can say like this: if somebody is at the front, means controller is going to receive the signal front, then your gate should remain open to allow the person to move inside the supermarket, or if it is at the exit one, so it can allow person to exit. So this is the situation. Other possibilities is rear, means gate is open and some at the rear point, then it should remain open. Otherwise, once it is going to, if try to close the gate, then the gate may hit the person. So you can say here, if the input is rear, then gate should remain open. Other possibilities you have the case of the both. So if you have the both, this means person is at the front pad also and person is at the rear pad also. So and gate is open, so it should remain open in this situation also. So this is the state diagram of your automatic door controller. Now you see, your controller is going to switch from one state to the other state. Sometimes it is in closed state, sometimes it is in the open state. So it transits from one state to the other state. And what is the input it is going to receive for transition? It is going to receive the four signals, and on behalf of the four signals, and depends on the states of the controller, it is going to decide whether it should transit the state or whether it should not transit the state. So here state is very important for the controller. It has to know in which state it is. So state of controller plays major role. So how much memory you need for storing the state? You just need 1 bit information for storing the state name, and means 0 or 1. So you have 1 bit information, either 0 or 1. You may assume anything, maybe 0 maybe corresponds to the closed and 1 maybe corresponds to the open. So you may think like this. So 1 bit memory is needed for storing the states of the controller. So see, very limited memory it has. But even having in this kind of limited amount of memory, it is going to do this kind of job. So controller knows that once it is in the closed state, maybe 0. If it sees that the state is 0 means closed state, then it think that I will transit to the open if and only if I am going to receive the input front. In all other three cases, rear, neither and both, I will remain in the closed state. So this is the decision it makes on behalf of the what? On behalf of the input, on behalf of the input and on behalf of the state. So two things for making the transitions of the controller, it requires two information. One is what? What is the current state of your controller and what is the input? If current state is closed and input is front, it will transit the state. If current state is closed, input is either both, neither or rear, it will remain in the same state. So it is not going to transit the state. Similarly, state is 1 means open, then on behalf of this information, your controller knows that I am in the open state. My state value is 1, means the state is open, gate is open. Then I will close the gate if and only if I will receive the input neither. So neither means no one is at the front and no one is at the rear. So when no one is at the no one is at the front and no one is at the rear, then it is going to change the state. So what caused the controller to change the state? What is the current state? This is, if this is the current state and your controller is going to receive the input neither, then it is going to transit the state. And this is the case of the state transitions. So it is going to transit the states. If controller is at the open state, it on receiving the signal front, rear and both, it decides that okay, since I am in the current state is my current state is open and I am going to receive such kind of signal, I should remain in the same state. It is not going to transit the state. So this kind of state transition is done on behalf of the input. So machine transit from one state to the other state on behalf of the input, and in this way actually you can say that machine is going to compute. So computation is done on behalf of the input symbol you are going to encounter and whatever is your current state, and then you decide that whether you have to transit the state or whether you don't want to transit the state. And this is the way of the machine is doing the computation work. Here actually we are assuming that you are entering in one gate and you are exiting in some different gate. So see, this is the way machine is actually going to compute. And this is the diagram. This is the state transition for your automatic door controller. So your automatic door controller is going to have this kind of state diagram, and with limited memory, it is able to do the excellent job for opening and closing the gates. And this is one of the example of your finite automata. So you can, if you go in the real life, then you will find some other examples also. This is just one example. You can have the other examples. What other examples you can see? Like you have the elevator. Okay. So in case of the elevator also, you have the same situation. Your elevator, state of your elevator can be floors, first floor, second floor, third floor, or whatever. And how it is controller of elevator is going to receive the signal on behalf of the switches, buttons you are pressing. First floor, you want to go first floor, or you want to go second floor, third floor. So it is going to receive the signal accordingly, and it knows that what is the current state, means what is the current floor, and on receiving such kind of signal, where to move. So again, you may have some more states here, but again, with the limited amount of memory, your elevator is also one example of your finite state machine. The design of such kind of elevator is done on the principle and methodology of your finite state machine. So this is other example of your real life finite state machine, FA. Other examples you can see dishwashers. Dishwashers is also other examples. Digital clocks, sorry, digital watches, calculator, digital calculators. So all such are the examples of your finite automata. So design of such devices are done on behalf of the state transitions. So these are the best examples of your finite automata. So what you have seen in case of the finite automata, this is some informal discussion of the your finite automata. So you see, once you have the finite automaton FA, then what you have? You have some sort of states. Your device, your F, how your work FA is going to work. It has some states. So we have here two states here. Okay. And as the name suggests, finite automaton, this means we must have the finite number of states. If you have the infinite number of states, this means how information is going to remember in this device. The information, how your controller is going to remember the information on behalf of the state. So once it is in the state this, it is going to say that okay, I am in the open state, and accordingly I have to do the task. Once it is in the closed state, it can do the task accordingly. So your controller is going to remembering the information on behalf of the transition state. So state, storing the state information in your memory is highly important here. So how many states you should have? If you are having the infinite state, and we know that accordingly you will need the amount of memory, so it means you have unlimited memory you need. So this is not the finite automaton. So that's why we have the name here finite automaton. You see that the finite automaton means we have the finite number of states in this machine. We don't have the state infinite. So one condition is that you must have the finite number of states. So number of states in your machine is finite. This is one thing. Other thing, your machine has transitions. Your means computation is done. This is the process of computation. Means the process of transforming input into the form of the output here. So how you're going, your machine is going to change its mind setup. Your machine is going to change its mind setup on behalf of the input signal. So once it is like this, it has, you have the front input, then mind setup is going to change, and from closed to open state is machine is going to move. So machine changes from one state of mind to the other state. So one most important thing is you must have the finite number of states here, and then your transitions occur. So you have the transitions, and transitions are done on behalf of the your states and your input. Now, since this is the automatic door controllers, so you can start from this state or you can start from this state. In the case of your device, machine is not supposed to decide from where you have to start. It has to start. You need to specify clearly that okay, yes, my gate is closed now, and now machine will start from the closed state. So you must have some state currently, and you let the machine now do the task. So you can say that current state or initial state. So initial state of your machine is closed, means machine has to start from this state. Means gate is closed at the morning, and machine has to start from this state, you can say. So out of these states, you must have to designate one state as the initial state. So we will call as the initial state. So this is the initial state you have. So for this case, we don't have any problem. This can become initial state. Machine means you have to explicitly tell the machine that okay, you have to start from this state. This is one thing. machine has no decision making power. So you can designate some state as this is the state where machine should start. And for some cases, most of the cases, you will have some destination properly. Your state transitions are done, and with the intuition that you are reaching to some sort of conclusions. So once you have achieved the target, once you have done the task, then you are moving to some states, and your ultimate goal of this transition is to your machine should be at the final state. Final state means where the problem is solved, where you want to reach. So out of such states, you will be interested to reach in some state. Like you may think that at the morning, the controller has the state closed, and we ask that okay, you have to start from this state, and this will become the initial state. At the end of the time, at the evening, you can say at 11 p.m. you have to close the supermarket, and then you have to close the gate. So your controller should come to the closed state, and this is the final destination of your controller to stop. So you can say that this is also the final state. So out of these states, some one state should be the initial state, and some states can be the final state. So you may be having the target in some complex cases to halt your machine in some states you are interested. But you have to start it only from only one state. So you explicitly mention that okay, machine should start from the one state. So on discussion of the finite automaton, we see that machine is of having the finite number of states. Machine changes its mind setup on behalf of the current state, and it is on behalf of the signal it is going to receive. Out of these states, one state will be designated as the initial state, so that machine should start from that state. And we also having the target to reach out some destination state, and that we will call here as the accepting state, or we can say that the final states of the machine. So this is the informal definition of your finite automata, and we have seen the real life examples of these kind of devices. So even having the small amount of memory, you can do some excellent jobs with the help of the finite automaton. The only way to remember the information here is, since you are not using any additional storage in this case, the only way to remember the information is with the help of the state transition. So you have to remember the states in which state your machine is currently in. Now we see the formal definition of the finite automaton. You can abbreviate as the FA. Is a 5-tuple. 5-tuple. So we can denote the F machine by writing the capital M here, capital M, finite automata, and 5 tuples. So it has 5 information. One is Q, other is sigma. We have the Q0. Okay, we have the delta, and this is the A. So here, like the grammar is your grammar is 4 tuple, and here your FA is 5 tuple machine. So your FA can be defined like this: M is equal to sum FA M is equal to Q sigma Q0 delta and A. So here Q is, we have the set Q. So Q is the finite set. So this is the finite set, and the elements of this set is actually called as the states of the machine. So you can say finite set of states. So Q is the finite set. Here you have finite. The number of the set must be finite, means you must have the finite number of states. Sigma is what? Sigma is a, again, finite alphabet. Okay. So this contains the input symbol. You have the input symbol. So input symbols you have. Sigma is again is the finite set. Q is the finite number of states. What is Q? So here actually earlier I pointed out that your machine should start from the one initial state. So Q is within the set Q. Q0 is within the set Q. Means Q0 is an element of Q, which is known as the initial state. So this is the initial state. So we have the initial state. So you must have one in, say I have written here Q0 for denoting the initial state. You can write in your own interest, you can give the different names, but you have to explicitly mention that, okay, this is the state which is in the queue, and this is the initial state. Your machine is going to start from this state. So you can mention. So there is no hard and fast rule that you have to mention Q0 as the initial state. You can take the symbol of your interest. Here, the information is A. I have written A. So this is A. And A is the subset of Q. And this is known as actually the set of accepting states. This is the set of accepting states. So you may have accepting states, or you can say final state. So you may have one final state, or you can have only all elements of the queue can be the destination. So that's why I have written that A is the subset of Q. This means A can be one state, or A can be any two states, three states, or even all states of the machine can be the final state. It means machine is accepting everything. So A is the subset of Q here. This is the subset of Q. Now the important thing is what? We have the delta. And delta is the state transition function defined as follows. How you can define? So this is the state transition, and on behalf of this function, your machine will transit from one state to the other state. So you can define mathematically like this: delta takes the input Q cross sigma and outputs any one of these states. So this is the transition function of your finite automata. Okay. So you will find this kind of transition function here. What do you mean by this? This means function takes some input. What are the two inputs? One is the state, and I have already told you at the earlier that machine is going to make the transition on behalf of the current state and on behalf of the input it is going to receive. So machine has to decide which state it has to move. Whether it should remain in the same state, or whether it should move to any of the states of the queue. That's why output is what? Output of transition function is any one of the states of the machine. So Q is the set of states, and this is the set of inputs. So your machine possibly will find the input like this, and you have the set of state. Like in the last example, we have seen the automatic doors. when you have the automatic door controller of, you can say that, so you have the controller of automatic door. So what you have seen here, so here you will find that state, how many states you have? You have the two states, one is closed and other one is open, like this. Okay, and here you have the inputs. How many inputs are there? You have the 4 inputs. One is neither, other one is front, other one is rear, and the last one is what? You can say both. These are the input. So you see, machine is going to make the transitions on behalf of this. So this is the set. This is the set of inputs you have going, and on behalf of that, machine will be in any one of the states. It may be in a closed state, or it may be in the open state. So machine can move to any one of these states. So these are the possibilities. So output of the transition function delta is, in the case of the automatic door controllers we have seen earlier, it has the 2 possible output. One may be the closed and other may be the open. So how machine is going to decide whether it should be in the closed state or whether it should be in the closed state? To see the possibilities, machine is having the function, your your automatic door controller is going to take the functions like this. So you have the delta is going to take the 2 inputs, like it first may be the closed, this is the closed, this is the state, and input can be anything. So for one state you have the 4 transition, you must show the 4 transitions. See, if you are having the closed state, you have 4 possibilities. One is both, one is neither, one is rear, and one is front. 4, because you have the 4 inputs. Your controller may receive, if you are in this state, your controller can receive any one of these 4 inputs. So whenever you are going to receive any one of these 4 inputs, then you are going to decide what to do. So like if you are in the closed state, you may can receive and neither. So this is an output of this transition function is what? If you are in the closed state, no one is at the front and no one is at the rear. You can easily see here. If no one is, you are at the closed, no one is at the front and no one is at the rear means front, neither, then you are going to in the output is what? The closed state. So this is the way you can, machine is going to make the transition, and this is the mathematical description of that. So when machine is going to receive the inputs, it is in the current state is closed, input is neither, then machine decides to go out of these 2 states, machine will go to the closed state. So output is what? The closed. This is the way. So this is one possibility. Other possibility, you are in the closed, you are in the closed state, and whenever you are in the closed state, you are going to receive the signal front. So somebody is at the front, you are at the closed state, the person is at the front. Where you are going? You are going to the open. So this is the, and this is the way you can define the transitions. So you remember that in case of the finite automaton, by definition of the transition function, here you will see that from every state you have to show the transitions for all possible inputs. From every state you have to show the transition for all such inputs. You should not leave any input. All possibilities will be there in any one of these states. So this definition says that transition function says that you are in some state and you can receive, for one state you have this much choices, this much possible inputs, and on behalf of such inputs you have to describe the transition function, what should be the output on behalf of such inputs if you are in the state, some states of the machine. So it is very, very important to remember that whenever you are in the some state of the finite automaton, then you have to consider all possible situations, all possible inputs. And you means you have to clearly specify the machine. If you are in the current, your current state is this, and you are receiving signal, you are receiving input out of the given inputs, then what to do? So for every possible inputs, you have to clearly specify with the help of the transitions or mathematical, you have to clearly specify that on if you are in this state and on behalf of this input, what to do. If you are not able to tell the machine, if you decide for some inputs and for some other inputs you have not specified what machine what to do, then this is not the case. This is not the finite automata. So in case of the finite automata, your transition function says that you must decide for all possible cases. Otherwise, we will if you are leaving some input, if you are not mentioning the transition for some inputs, then machine has to make the decisions, means machine has to make the guess if such inputs comes, what to do. So we will talk such machines later, but at the beginning you understand that since we are going to discuss the finite state machine, and here once I discuss the finite state machine means I am talking about the deterministic finite state machine. Deterministic. So once I say FA, it means I am talking about the deterministic FA. And in case of the deterministic FA, it is we have the transition function. Transition function you can define like this, and this says that from every possible states you have to you might have all such inputs, and clearly you have to specify on such input what is the output, where machine should go. So this is one thing. So from every state you have to give the transitions for every possible inputs. So this is the formal definitions of your finite automata, and the things is very important to know about the transition function, because transition function plays major role here. Okay. So one way to describe the machine with the help of the kind of this transition diagram, you have the transition like this. So with the help of the state transitions we have defined. Other way to define the machine is with the help of the, you can have the mathematical, you can define the machine by writing the set of transitions. So this is one transitions you are mentioning. Then you can mention the other transition. You are in the close, you are going to receive the rear, then you are receiving the both. Then you can define the transition for the open state. You can go for the open state. If you are in the open state, you receive the signal. All these signals neither rear, front, both, and then you can find out what should be the output. So either the machine with the help of the state diagram, like earlier we have seen, or you can describe the machine with the help of the by writing the set of transition function. This is the set of transition function, and this set of transition function actually you can we have reflected in the transition diagram. So there are two ways to describe the finite automaton. Either you can write the set of transition function, or with the help of the state transition diagram we have seen earlier, we can describe. An arrowhead says that you are moving to the state. Your state is going to change. So from current state, you are moving to the open state like. So arrowhead is pointing to the new states you are moving, or states you are moving, maybe in the same state. So if you are in the same state, means this is the kind of loop, means you have them in the same state. Okay, I think we have done some basics of the finite automaton at the beginning. In the next classes, we will see some examples of such automata.